In this video we show you an alternative way to build the line following module as compared with the method shown in our earlier video. Before you build the line following module of the Arduino based Primo robot, we recommend that you watch this video as it shows you how to avoid problems. The first step in building the Primo robot was to break apart the set of circuit boards that make up the electronics and chassis of the robot. Among the chassis parts you will see two small printed circuit boards that make up the line following module. On the one part it says photo-transistors, on the other part it says LEDs. Do not break these two boards apart, but keep them together as you see them here, because that is how we're going to build the line following module in this video. First, you will want to locate the photo-transistors, which can be identified by looking into them from the top, where you will see a small black chip of silicon on the inside. To get started, you will need some Bostik press stick to hold the parts in place while you solder them so they don't move around and end up soldered in the wrong place. First, we place the photo-transistors on the board in the correct places. There are two sides to the Primo robot circuit boards. On the one side, all you can see is the copper tracks painted over with red. On the other side, you can see white markings that indicate where to put the parts. While the parts on a printed circuit board are usually placed on the silkscreen side, in this instance we have to place the photo-transistors onto the plain red side of the printed circuit board, so they will point downwards onto the maze table while the silkscreen markings remain visible from overhead the robot. Take care when placing the photo-transistors that the short leg of the part goes through the hole that is nearest the flat edge indicator on the silkscreen. If you look carefully at the silkscreen, you will see the outline of the part is a broken or dotted line. That indicates the part goes on the other side of the PCB. This is a close-up view of the soldering iron tip before it is wiped clean on the wet cellulose sponge on the stand of the soldering iron. This view shows what the tip looks like after it has been wiped. Notice how the excess solder and carbon deposits have been cleaned away. Before you start soldering, it is always a good idea to touch some solder wire onto the point of the iron and then wipe the tip again to get a gleaming point. You can touch the soldering iron tip into the joint again to make sure the solder has in fact melted to both parts. Here you can see the result of not wiping the tip of the soldering iron often enough. There are dirty carbon deposits on the circuit board. Now we can see this is a better result because the tip of the soldering iron was absolutely clean. If you wipe the tip of the soldering iron on a wet cellulose sponge every time you pick it up, you can also perform high quality electronics grade soldering that will result in more reliable electronics for your robot. This is what the line following module looks like once you've placed the photo-transistors on the board. The next thing that needs to happen is the 4.7 kilo ohm resistors are placed on the photo-transistor section of the line follower module. These parts are marked with yellow, purple, red and gold stripes, and they go on the same side of the printed circuit board as the white silkscreen markings. These are some of the other parts you will require to make up the line following module. But don't panic if your parts look slightly different, as Mantech is making improvements to the kit all the time, and what you have in your kit, if not exactly the same, will work just as well if not better. The bright white LEDs look the same on the outside as the photo-transistors that you have already placed on your printed circuit board. However, they are quite different in that they create the light for the module rather than receive the reflected light back from the maze table. When you look through the lens of a bright white LED, you will notice that they are yellow inside. In the next step, we place the LEDs. But we are not going to put the parts down flat right against the printed circuit board. Rather, we are going to use M3 nuts from our robotics kit to space the LEDs a little bit off the board, which will give us some space under the part to bend it at an angle. Before we proceed, Make sure that the part is inserted into the printed circuit board the right way around. The flat part on the edge of the body of the LED needs to match the silkscreen outline pattern on the printed circuit board. Once we are sure the LED is oriented correctly, we take some press stick and 2 M3 nuts and use the press stick to hold the nuts underneath the part so that the part is held the width of the nut off the board while we solder one leg of the LED. Once one leg of the LED is soldered, we can remove the nuts and check the part is spaced correctly up from the printed circuit board. Here you can see how the LED on the right hand side is spaced up from the printed circuit board, leaving some legroom to bend the part over, which we will do once the other LEDs are also mounted. Now we solder the other leg of the first LED and then proceed to the next LED. Once all the LEDs are soldered into place, we can slow the video down to normal speed so you can see how we bend the LEDs over slightly, which will place the beams of light in the right place underneath the row of phototransistors on the maze table surface. Don't worry about the exact angle right now. Once the line module is mounted on the robot, we will be able to check the beams of light from the LEDs land in the correct spot on the surface of the maze. Clip off the excess lead length of the LEDs and then place the current limiting resistors on the circuit board. The current limiting resistors that protect the white light LEDs against excess current are 220 ohms, which translates to a color code red, red, brown and gold. Take note that we only place the 220 ohm resistors on the PCB after we have soldered the LEDs onto the board so that the resistors do not get in the way while we are mounting the phototransistors using the 3mm nuts to create a little bit of extra space underneath the parts. Notice in this image we have a larger resistor with the same color code. The larger resistor is for use on the white breadboard on the top of the robot and will not fit nicely on the line module. So make sure you have the correct resistors and only use the small 1/8 watt resistors on the line module printed circuit board. What typically happens is when one first opens the Primo robot kit, all the parts tend to get mixed up. When you open the kit for the first time, take care not to mix the parts up. The next step is to take some wire and join the two sections of the printed circuit board to one another. I've simply taken some of the excess LED wires that we cut away after the parts were mounted and bend these over to make jumper wires to connect the front and back sections of the line module. Flip the board over and solder on the back and the front. Notice how we take a straight piece of wire, then bend it over into a U shape before we use it as a link. If you want your line module to be a little bit more rugged, you could use 4 jump over wires instead of 2 jump over wires like we've done here. There is a possibility that light can spill over from the bright white LEDs directly into the phototransistors without bouncing off the maze table, which would not be ideal. You can put a strip of black insulation tape between the row of phototransistors and the LEDs. One could also make a light baffle between the rows of parts and even build a light baffle around the line module to prevent ambient light, in other words the light in the room where the robotics maze is situated, from interfering with the operation of your robot. Place the tape so that you do not block the path of the light reflected back from the maze table into the line module's phototransistors. The next step in preparing your line module is to solder a connector strip to link the power, ground and sensor outputs to the robot. Find a strip with 5 pins or take a pair of clippers and cut a strip of 5 pins from the longer piece of pin strip. Do the usual thing of holding the pin strip in place on the printed circuit board with blobs of press stick and solder all the pins only once you've checked it's properly in the correct place. Now it is time to find the parts to locate the line module onto the body of the robots. Your parts may be a little different, but should look something like this. Use spacers and washers and spring lock washers to get everything to fit together nicely. Take care when working with plastic parts not to over tighten and damage the threads. Once the line module has been mounted onto the robot, we can check for how high the module is off the table, and then adjust the angle of the LEDs to create little pools of light straight underneath each phototransistor. What seems to work best is if the distance between the line module and the maze table surface is about 10 mm or 1 cm. Now it is time to connect the line module to the microcontroller on the robot using wires from the breadboard kit. Take care when stripping the insulation from the ends of the wires not to nick the actual wire, as this will weaken the wire and could result in bits of wire breaking off and blocking up the holes in the connectors and the breadboard. If you have access to a 3D printer, you can make your own wire stripping tool like this using 2 blades from cheap pencil sharpeners. You can also buy a wire stripping tool like this from mantech.co.za. You can also use the side cutters, but the wire tends to get nicked and bits break off and clog up the holes in your breadboard. Now link the line module to the robot, making sure plus is connected to 5 volts, minus is connected to ground, and the left, middle and right sensor outputs are connected to analog 0, analog 1 and analog 2. When you switch the robot on, if everything is connected properly, the bright white LED should light up. It is a good idea to mark the left and right side of the robot and the line module to prevent confusion when you start testing the line module. Looking from the top of the robot, we can see the left and right hand sides. If you have a private pilot's license or you're familiar with sailing terminology, then you will know that port is on the left hand side if you're facing the front of the vessel, and starboard is on the right if you're facing the front. Notice how we have connected the line sensor outputs to the breadboard and used another set of wires to connect the sensor wires on the breadboard to the analog inputs. At this stage you will want to load some code into the microcontroller and do some testing. Get in touch with us to acquire the documentation and example programs for the Primo robot. Once you have the test program uploaded to your robot, you should see messages like this in the serial monitor as you move the robot over a line made of black tape on a white background. You can also set up some LEDs on the breadboard of your robot that switch on when the corresponding phototransistor is over the white maze table surface and switch off when the phototransistor is over the black tape. To find out more about how to build and program your own robot from electronic parts, visit robotscience.co.za and subscribe to our YouTube channel www.youtube.com/electronicsafrica. Once the line following module is built and tested, and you're certain that everything is working properly, the next stage is to upload our line following programs to the robot. In this sequence, you will see that the robot is only using the 2 outer sensors to follow the line, which it does with a lot of wiggling. In this sequence, you will see the robot is able to follow the line more efficiently without wiggling so much. This program is set up to use all 3 sensors, so that when the robot is over the straight line, it can drive straight.